Welcome to today's lunch talk in our lunch talk series of DeCarbCH. I'm Gianfranco Guidati. As usual, I will be your host today. And the speaker we have is Lukas Braunreiter from ZHAW. His topic will be Beyond the Numbers, Why Energy Scenarios Often Fail to Connect to Decision Makers. And I find both the speaker and the subject extremely interesting. So, Lukas, I would like to hand over to you, and the floor is yours.
Thank you for the kind introduction. Lukas Braunreiter. I work for the Innovation Systems Group at ZHAW. And basically what we do is look at the role of innovation in socio-technical transitions. And we're mostly doing that for the case of the energy transition. But we've also done some research on food-related agri-food transitions. So we try also to branch out a little bit there. And sort of my research focus in particular is on the role of energy scenarios for the energy transition, as you just mentioned, Gianfranco. I was talking about a metaphor about comparing the size and the longevity of the sweet projects compared to the sour. And so sour is really a short-term project, like a trailer trying to provide some interesting insights that might as well provide useful for the sweet projects. And this is hopefully what this talk today will do. And as with all the sweet projects, it's financed and supported by the Swiss Federal Office of Energy. Gianfranco mentioned that I've been working on the role of energy scenarios for a long time, sometimes together with modelers, but it's important to remark, I am not a modeler myself. So I'm a social scientist, therefore also using social scientific methods, such as here, sort of the underlying theory for what I do is the sociology of expectations. And basically, in a nutshell, for you, what you need to understand is this branch of research says, well, energy scenarios, they are really important because they sort of make imaginable where we need to go. For example, in relation to a renewable and sustainable energy future. And so in that sense, they say, well, we need energy scenarios because we need to be able to imagine where we want to go. And if we then go back to the question, well, who actually uses energy scenarios? It's of course important to know, well, which of these existing energy scenarios are actually used and which ones have an impact at the policy making, at the decision making level. That's enough, I think, about the theoretical framework. The empirical research questions are much more easily understandable and much more hands-on, as it should be for a University of Applied Sciences, which are how and for what are energy scenarios used, who is using them, and sort of what makes them credible or useful, what kind of attributes do energy scenarios need to have. And we've been working on these questions for quite some time. So we started by asking these same questions among the Swiss energy research community back in 2018. And more recently also did a study, quite similarly also with lengthy interviews on Swiss utility companies and their specific use of energy scenarios. Now, while we learned quite a lot about the finer mechanics and how actually individuals use energy scenarios, there was of course always a rather small number of participants, and this is also what sort of one of the goals of the SOUR project is to get a more comprehensive overview and sort of be able to ask more users and also more diverse user groups on how they interact with energy scenarios. If you look at sort of the general relevance of energy scenarios, we don't have to go that far. Sort of a key event was, of course, after Fukushima 2011, when the Energy Perspective study was published, and which sort of formed the basis also then for the Energy Strategy 2050. But more importantly, I would say for this kind of research we're doing now is sort of the whole energy modeling community that has been established over the last decade or even longer in Switzerland. Because I mean, at almost every university or higher education institute, you have these modeling communities which are active. And what we can say is that there are over 100 active modelers in Switzerland. And in fact, as you will see, also we got, in our survey alone, we were able to reach 100 researchers who self-identify as energy system modelers. And also, if you look at the SWEET consortia and their goals, it's often the case that energy models or energy scenarios form the basis of their research, or that scenarios are even the output or the goal that is being produced within these consortia. If you look at the individual level, of course, you have then models which can produce different scenarios. And what I find kind of amazing is quite recent research by the group of Stefan Pfenninger, who is now in the Netherlands. They sort of looked at simply techno-economic pathways to decarbonize Europe, and Switzerland, in that case, part of Europe, and found that there exist over 400 different pathways to decarbonize Europe. And sort of the question then, of course, that follows is, well, what does this follow the science slogan, which you all often hear about around climate activists or politicians? What does it mean in this context? So how should users interact with this huge diversity, these huge assets that this modeling community provides? And how is this diversity useful? And in what sense is it maybe also adding complexity, as it may be overwhelming from the point of view of a user when you have this diversity of research institutions, modeling approaches that is apparent in Switzerland. Now, with this increasing relevance, but also prevalence of models, came also increasing critique. And this is not coming from Switzerland per se, although we do have researchers at the forefront of this, such as Evelina Tutnevite and so on. It's mostly due to the fact that models also play an increasingly important role in the IPCC. If you look there, sort of how important are integrated assessment models in these various IPCC reports over the last decades, they become more and more important, and they're also informing transition research more generally. And sort of in that way, and of course, researchers also began to critique these models. For example, this techno-economic focus I spoke about, with researchers calling for more social aspects that should be part of it. And as you know, the upcoming SWEET COSI, co-evolution consortia will try, for example, to tackle this part. There are also a lot of researchers calling for more participative or transdisciplinary modeling, so bringing in stakeholders or the eventual users. And you also have researchers trying to bridge sort of this techno-economic analytical viewpoint with more social disciplines like sociology, but also transition research more generally. And what I think what has been established is sort of, I call it the political economy of models and scenarios, where a lot of researchers are, for example, criticizing, well, for example, the 1.5 degree Paris climate target can only be kept alive because we have, for example, a lot of negative emission technology scenarios like carbon capture and storage, CCS, in IPCC scenarios. And this is scrutinized a lot. And sort of these research-based criticisms were also important for this ZHAW project, because we wanted to know which of these actually matter for the users and what do the modelers themselves think about these. And so that's why we designed the survey because we really wanted to provide a comprehensive view of the situation and the interaction between modelers and users in Switzerland. So coming away from these individual case studies for focusing on single target groups or user groups to a more comprehensive approach. I think on the side of the modelers, we were able to do a pretty good job, also thanks to also the collaboration, of course, with the SWEET Cross initiative and other modeling communities who shared the link to the survey. We were able to reach 105 energy system modelers, basically for all different research institutions, covering PhD students to professors and so on. On the side of the modelers, we thought, okay, based on our initial interviews with the modeling community, who is the key target audience? Who are the users most likely to use model-based insights? And of course, there the SWEET consortia stakeholders are key target groups also there, thanks to the collaboration with SWEET Edge, Pathfinder, and not least DeCarbCH. We were able to include 76 stakeholders from this panel. And besides that, we also thought, well, it might be a good idea to include energy startups, because they sort of depend on which direction, which pathway the energy future takes. For that, we used our in-house innovation monitor, which also has an underlying database of energy startups. Then what we also often heard from energy modelers, well, of course, decision makers, policy makers at the cantonal or municipal level are key. And there we were able to get 43 respondents. And lastly, we also shared the link via LinkedIn or via email, and sort of 73 various participants then also got into our sample. So like two broad groups, on one hand, the modelers, on the other hand, the users. And this was really important to us, that we not just included like a wish list of what the users want, but also the self-perception of the modelers themselves, where they think their work could be useful. And what you see here is a first indication. We simply wanted the modelers to name, to specify, well, which actors do you think your output could actually be useful for? And what you see here is just a big list of potential users. And what is evident is that the first two, the biggest target audience, according to the modelers, is sort of the academic world. So on the one hand, the scientific community, who maybe wants to cite a certain study, and on the other hand, also other modelers, for example, when they want to use certain data package or see what assumptions are coming in. And then you have a lot of non-academic user groups who modelers think their work could be useful for, ranging from these authorities at the different federal levels to investors, NGOs, and so on. And this was important for us to see, because in a lot of studies, we simply see mentioned, well, our work can have an impact at the policy or decision-making level, but it's rarely spelled out who they actually think this is. After its initial assessment, we also asked, well, which of these potential users that you see, where do you know which users actually use your stuff? So which known use cases exist? And here we see the picture changes quite dramatically, in the sense that these academic purposes, so other modelers or the research community more generally, they are known to be using energy scenarios and models in reality. Whereas all the non-academic use purposes, there it's like a large gap between the modelers who think it could be useful, but to date, not enough, or quite few of them are actually using them. And I think what this shows is there's a lot of potential for the research community, for the modeling community, to have a greater impact in the future if we are able to translate modeling-based insights and show the users why it might be useful. Then we also went into why this gap might exist. And what you see here is, on the one hand, what kind of interaction and communication formats the modelers offer, and what the users would want to have to interact with energy models or scenarios. And what you see again is this divide between sort of academic purposes, so scientific papers, but also open source initiatives like making your code available, making all the assumptions transparent, which is, I think, really important part of this open source trend in the research community, which is very good and very necessary, but not that relevant from a user perspective. So users want different kind of interaction formats. For example, podcasts or videos, which also maybe is an indicator of there may not be as analytical in their use case as modelers think, and more want an overview of maybe key results and also interactions maybe with modelers themselves, because as you see, workshops or seminars are also quite highly rated. And we also sort of went on to compare the perception of energy scenarios and whether there are differences. I won't go through all of these points, but basically what you see here is a large agreement that users and modelers think that energy scenarios are important. So it's not just social scientific research, but also the users themselves who say for both energy policy and for energy industry, it's actually very important. And also what was quite nice to see, there's this common criticism, well, that models are black boxes anyway, and therefore not that useful. This is something that is not shared by this panel of potential users we got here. And so that this black box perception is not something that is hindering the use of energy scenarios. When we look at the questions that asked, well, how can we improve energy scenarios? How can they be more useful? What we see consistently over all these items is the users are much more demanding than the modelers are of themselves. And again, not going through them all, but maybe one on the right side that is quite indicative is users would like to have probabilities for different scenarios. So how likely is it that we get this future, this pathway? And of course, if you talk to modelers, they very quickly talk about, well, methodologically speaking, we cannot and will not attach probabilities to scenarios because we create what-if events that are all sort of strictly hypothetical and explorative in that sense. So there we have this divide between what users want and what modelers can provide. Also, what we saw when we look at the content and what users want to have, specifically in relation to what the COSI consortium will be doing, we asked sort of between this divide of technological aspects, economic aspects, and social aspects, what matters to you? And what we see for the users, these three aspects are more or less equally important. And it's not even the case that the costs, which are nowadays, for example, in the political discussion around the new climate law, which will be decided soon, are even more important than technological or social aspects. But for the modelers, they clearly see this focus on techno-economic aspects and the social aspects to be the least important. But that's sort of more on an abstract level. We also try to go more into detail. And of course, then this depends on the model you have, whether it is realistic to include these aspects or not. But nevertheless, we ask them for different social aspects that could be integrated into energy systems in general, such as behavior and lifestyle of citizens, the impact of political parties or lobbies, or also climate movements, or also modal shifts, in addition, for example, to electric vehicles. Would you like to have these aspects? And here again, what we consistently see, modelers say, yes, we would like to have that. And the modelers say, well, no, that cannot or should not be part of the models. And sort of to conclude this first part of the ZHAW project, what we see is we really have these two worlds. We have on the one hand, the modelers who are doing a very good job of having more powerful, more accurate models, more temporal resolution, more spatial resolution. And on the other hand, we have the users, which are species we don't know that much about, and also our understanding of how they interact with energy scenarios is, compared to this increasing sophistication on the modeling side, still very basic. This is where I think social science could come in to improve this situation, because I think it wouldn't be fair to say, well, modeling communities need to also be able to translate and visualize the results better. It should not be the responsibility of the modeling community alone, especially not individual researchers, but we need to have structures in place accompanied by social scientific research to improve the use of energy scenarios. And I think the big chance from a Swiss view is that we have all these modeling approaches, these modeling communities, which are institutionalized at the different universities. And we can use these because they will be able to have personnel and resources anyway to adapt their models to create new versions. And what I would suggest to do is, I call it the life cycle perspective on energy scenarios and models. So once the scenario report is published, try to also look at its impact. Who is reading it? Who is trying to use it? And then integrate these feedbacks, mechanisms, and impact metrics also in the development of the next round of scenario to maybe make it more user-friendly. And the danger, if we don't have this, is what happened recently, just some snippets from the German discourse about the upcoming climate law, where single scenarios within individual scenario studies are just cherry-picked out to drive a certain agendas. And I think this is not something that is unique to energy scenarios and models. This is true for energy or research in general, that things can be taken out of context and cherry-picked. But with energy scenarios and models, due to their explorative nature and also the role of assumptions, it's maybe more likely that this happens. So I would say, while we need energy research and energy scenarios from a transition research perspective, simply because we need to change our energy systems quite radically and quite fast, I think a special responsibility goes to research-based models and scenarios, because there, of course, are also consulting companies, there are fossil fuel companies producing energy scenarios, and in a way, research-based scenarios are acting in a market. And if Shell or BP can produce a more compelling report, a Shell or BP or IEA report or whatever is more likely to be used. And so I think that's why we need this embedding of research-based scenarios. And that's why I think also long-term consortia like COSI or the SWEET Cross initiative are actually important of providing that structure. And finally, I think more useful energy scenarios are also targeted modelers themselves should have, because I think many of them are also intrinsically motivated to have an impact beyond science. And I think what we can establish with the ZHAW projects in our research, for now, the impact is mostly scientific, mostly academic. And if you want to have more useful, more impactful energy scenarios, they also need to be recognized by the users as valuable tools. And I think if we can make that link better in the future, there is a great chance that this might happen. That's it all from me. I hope I wasn't too fast. I'm, of course, very much looking forward to discussion and to your questions that you might have. Thank you.
Thank you, Lukas. I must say, I found it fascinating.